So, student, today we are going to see the concept of one of the physics phenomena, which we call as a bits. Now, what this bits is, in this bit combination, we are going to consider the superposition of waves and the formation of stationary waves. Now, up till now, when we have seen the formation of stationary waves, in that formation of stationary waves, what we are seeing that there are two waves having same amplitude, same period, traveling along the same line, but in the opposite direction. Will get superimposed on each other, then we will get the formation of stationary waves. Right? Now, in case of this wave formation, now we are going to consider here as a two sound waves. Now here we are going to consider for bit formation sound waves. So two sound waves. These two sound waves of equal amplitude but slightly different in frequency. So different frequency. Traveling along same direction will get superimposed on each other. Then the result of that superimposition of waves will be given by superimposition of these two sound waves gives the formation of alternate maximum sound intensity point and minimum sound intensity. And that is to be called as a bits. So what is the basic principle behind this formation of bits? The formation of bits we will get only when two sound waves of equal amplitude, slightly different in frequencies, traveling along the same direction will get superimposed on each other. Then the effect of superimposition will give us a sound waves of varying intensity, that is maximum intensity, minimum intensity. So varying sound intensity waves we are getting. And that will give us the formation of waves. Clear? So now, what I will say that in this formation of bit, I can consider the sound wave. So its displacement, let's consider first sound wave, displacement is y1, which is equal to nothing but a sine 2 pi inside the bracket. Here, inside the bracket, what I will say that here is nothing but your nt, frequency is n1, minus x upon lambda. But now here what we are saying that your sound waves are starting from the origin. The sound waves are starting from the origin means what I can say that in this equation I can put x is equal to 0. And when this I put x is equal to 0, so this equation will become as your y1 is equal to nothing but a sine 2 pi into bracket n1. This is the first sound wave. Then I can write displacement equation for second sound wave. Y2 is equal to a sine 2 pi, slightly different frequency. So frequency is n2 into. So what is the thing? These are the two sound waves. Their amplitudes are same. They have a slight different frequency and they are traveling in the same direction. Such two waves will get superimposed on each other. So superimposed on each other means according to principle of superposition of waves. Resultant displacement y is equal to y1 plus y2. That is your principle of superposition of waves. What is that? We have seen. When two waves are traveling through a medium, will get superimposed on each other. Then at a point, we will get a resultant displacement. At the crossing point, we will get the resultant displacement. which is nothing but the sum of individual displacement produced by each wave. So individual displacement of first wave is y1. Individual displacement of second wave is y2. So addition of their individual displacement. The addition of individual displacement is what? Y is equal to nothing but y1 plus. Clear? So this is nothing but according to, here I can write the reason, according to principle of superposition of weights. PSW, principle of superposition of weights. So now I can here put the value of y1 and y2. So what I write? Y is equal to y1. What is y1? A sine 2 pi n1 t plus a y2. Y2 is what? A sine 2 pi n2 into t. Getting? Then in that, which factor is common? A. So that a factor I will get out of the bracket. What is remaining? Sine 2 pi n1 t plus sine 2 pi n2 t. Clear? Now, I can use trigonometry. For this 2 pi n1 t, I can assume A. For this 2 pi n2 t, I will assume, means what I am getting inside the bracket? Sine A plus sine B. And sine A plus sine B by trigonometry, how we are going to solve? Sine A plus B, we have a formula. Sine A plus sine B can be written as 2, right? 2 sine A plus B by 2 into cos A minus B upon, right? So I can use this formula. Now A is what? 2 pi n1 t. B is what? 2 pi n2 t. So what I write now first? First factor is 2. So 2 as it is. Sine A plus B upon 2. Now in that A plus B, 2 pi t is a common. So what I say? 2 pi in bracket n1 plus n2 upon 2 into B. This is your sine A plus B by 2 into what? Cos. What is that? A minus B by 2. So again I write into. Here I write cos 2 pi into bracket n1 minus n2 upon 2 into 2. Clear? So I am getting this. So now I will write down here as it. Y is equal to this 2 factor I take outside. So 2a. What is the thing remaining term? Sine 2 pi into bracket n1 plus n2 upon 2 into t into what? Cos 2 pi into bracket n1 minus n2 upon 2 into 2. Clear? Now this equation, instead of this 2a and this cos term, I can write y is equal to capital A sine of 2 pi into bracket n1 plus n2 upon 2 into 2. Now this is nothing but my equation of progressivity. So what I can say that when two sound waves of equal amplitude, slightly different frequencies, traveling along the same direction will get superimposed on each other and getting a progressive wave having resultant amplitude A. Clear? So I am getting this equation. Fine. Now here, when these waves will get superimposed on each other, what I have told you that we are getting the maximum intensity point and minimum intensity point. And your intensity I is directly proportional to the square of amplitude. So if amplitude is maximum, then intensity is also maximum. Fine. So now from this amplitude value, I can find out the maximum amplitude point and minimum amplitude point. So here what I'll write for amplitude. What is our amplitude value? Our amplitude value is equal to 2a cos of 2 pi into bracket n1 minus n2 upon 2 into t. Right? Now when I want maximum intensity point, so I'll say that if I want intensity to be maximum, means what? My amplitude should be also maximum. And to get amplitude maximum, so I'll say that A max is equal to nothing but positive negative to it. A, your amplitude varies with cos angle. And cos angle has a maximum value plus 1, minimum value 0. And what I want A square. So A is plus 2A. Still A square is maximum. And A is minus 2A. But still A square is maximum. Means your amplitude maximum value is what? Positive negative 2A. Is it right? Now if your A max is equal to positive negative 2A. So what I substitute here? A max value I substitute here. Positive negative 2A is equal to 2A cos of 2 pi into bracket n1 minus n2 upon 2 into, from both sides this 2a will get cancelled. What is remaining? Plus minus 1 is equal to cos of 2 pi into bracket n1 minus n2 upon 2 into, means your cos angle, this angle value is value plus 1. So when cos 0 is there, I am getting plus 1. When there is a cos of pi, I am getting minus 1. Again cos 2 pi, I am getting plus 1. So now that values, now I am going to substitute. So now your cos values I am going to substitute here. So if I am going to put your cos values, means cos angle. What is angle? Now angle is this angle. So angle value is what? 2 pi into bracket n1 minus n2 upon 2 into t. If this cos angle is 0, I am getting plus 1. If cos angle is pi, I am getting minus 1. Again 2 pi, I will get plus 1. Then 3 pi, then I am getting minus 1. So in that manner, there are different values of cos. So first value I am going to put theta value as 0. If this theta value is 0, so I will equate 2 pi n1 minus n2 upon 2 into t is equal to 0. So what happens? This 2 factor will get cancelled. Getting? Then what I am getting this t. This t is equal to nothing but 0. So at first time I am getting this t factor is equal to 0. So for your maximum value, I am getting maximum amplitude when time t is equal to 0. So this I am calling as a t1. At t1, I will get A max, which is equal to nothing but 2. Then second value, I will say t2. Now t2 means for t2 value, I can consider this condition. What is that? 2 pi n1 minus n2 upon 2 into t is equal to pi. So from both sides, this pi factor will get cancelled, 2 factor will get cancelled, and t2 I am getting as 1 upon n1 minus n2. Means for time interval n1 minus n2, I will get your amplitude maximum value, which is nothing but as a minus 2. Similarly, I can find out next T3. For T3 value, now I can assume angle value 2 pi. So from both sides, this 2 pi factor will get cancelled. So what I am getting value of t? Value of t is nothing but 2 divided by n1 minus. Are you getting? Means in short, what I will write down here, I will get amplitude plus 2a at 0 minus 2a at time interval 1 upon n1 minus n2. I will get again plus 2a at time interval 2 divided by n1 minus n2 and so on. So next time interval I am getting 3 divided by n1 minus n2. So at this time interval, I will get amplitude maximum value. At this particular time interval, I am getting A max is equal to positive negative 2A, and therefore I am getting intensity is max. And when intensity is maximum, then that point of sound waves are to be called as the waxing points. So for waxing point, amplitude is maximum, intensity is max. So that we will get it when the bits will be on. Clear? Now, I can go for the minimum amplitude point, where I get the minimum amplitude point. So when amplitude is minimum, I can say that when amplitude is minimum, intensity is minimum. And amplitude minimum value is nothing but your 0. Amplitude minimum value is 0 means what I can say that this A value is 0. So instead of A, I put 0. So what I write 0 is equal to here, I will say it is equal to 2A cos of 2 pi and 1 minus n2 upon 2 into t. Are you getting? Means now here I will write down as a, now your angle values. Angle values is what? Cos of angle value is what this? 2 pi into bracket n1 minus n2 upon 2 into t. When cos theta is 0, when angle is pi by 2. Cos 90 is 0. Cos 370 is also 0, means t pi by 2. Then I can say that for 5 pi by 2 also cos angle is 0. Means at this particular angle, I will get it, the amplitude as a 0. So now I can find out the time interval. So first time interval t1. For t1, what I am going to equate here? For t1 value, I am going to equate 2 pi into bracket n1 minus n2 upon 2 into t is equal to pi by 2. So what happens is pi factor will get cancelled from both sides. Is it right? This 2 factor will also get cancelled. And what I am getting value of t? T is equal to nothing but 1 upon 2 into n1 minus n. So this value I am going to call it as a t1. So I am getting t1 value here. Right? So I will say that I am getting here as your t value. I am getting this t1 value, which is equal to 1 upon 2 into bracket n1 minus n. This is my first time interval. Now I can find out for second time interval. That is for when I am in the next, which time interval I am getting amplitude 0. So next time interval I will say t2. For t2, what is the condition? Angle is 2 pi n1 minus n2 upon 2 into t is equal to 3 pi by 2. So that I can equate now. So what I say 2 pi into bracket n1 minus n2 upon 2 into t is equal to 3 pi by 2. So what happens here? 2 factor will get cancelled, pi from both the sides will get cancelled. And now what I am getting t. This t factor that I am going to write t is equal to what? 3 divided by 2 into bracket n1 minus n2. So at this 3, 2, what I am getting? I am getting amplitude is 0. Means now here I can say that is I will get amplitude minimum, which is equal to 0. So that point I am going to call it as a minimum intensity. And that point I am going to call it as a winning point. So at winning point, I am getting intensity is minimum. So which time interval I am getting? First time interval. I will write down here. The first time interval T1, I am getting as a 1 upon 2 into bracket and 1 minus n. What is second time interval I am getting? Second time interval I am getting 3 divided by 2 into bracket and 1 minus n. Similarly, I can find out for third angle. So for third angle, I am going to equate which theta? 2 pi and 1 minus n 2 upon 2 into t is equal to 5 pi by 2. Again from both sides, 5 factor will cancel, 2 factor will cancel. So what is remaining? Your t is equal to nothing but, are you getting 5 divided by, so you get next time interval 5 divided by 2 into bracket and 1 minus n. And so on. Where I am getting the minimum amplitude. So at this time interval, what I am getting? Amplitude is minimum, which is equal to 0. So intensity is also minimum, which is equal to 0. And that points are to be called as your winning points. So see here, at what time interval I am getting waxing? Waxing means what? Amplitude is maximum, intensity is maximum. So at waxing point, I am getting maximum amplitude, intensity maximum. At winning point, I am getting amplitude minimum, intensity. So see here. Now I can find out period for waxing. So I'll write down period. That is capital T of waxing, which can be written as T2 minus T1. What is T2? T2 is 1 upon and 1 minus N2 minus 0. So what I am getting period of waxing, which is equal to 1 upon and 1 minus N. That I am getting period of waxing. Right? Period of waxing means what? What is the time required to obtain alternate maximum intensity point? That is called the waxing. Same thing, I can find out the period of now winning. So here I am saying period of winning T is equal to T2 minus T1. What is T2? T2 is what? Here I am saying T divided by 2 into bracket and 1 minus n minus 1 upon 2 into bracket and 1 minus n. If I do the subtraction, what I am getting period? T minus 1, 2 divided by 2 into bracket and 1 minus n. 2 factor will get cancelled. Means period is equal to what? 1 upon and 1 minus n. And this is period of what? This is nothing but your period of winning. Winning means what? Amplitude is minimum, intensity is minimum. So what is our final conclusion? Period for waxing is 1 upon n1 minus n2. Period for winning is also 1 upon n1 minus n2. Means both the period of waxing and winnings are same. So in simple language, what I can say that the maximum amplitude displacement point will be getting for a time interval. After that same time interval, I will get it the minimum intensity. Right? And from that, your question arises. The question is nothing but show that the period of waxing and the period of winning is equal. Right? While what is waxing? Waxing means maximum amplitude. Means sound intensity is maximum. What is winning? Winning is amplitude is minimum. Amplitude is minimum means what? Sound intensity is minimum. Right? And one waxing and consecutive one winning togetherly gives us the 1 bit formation. Now here I am getting period. From period, I can write down for frequency. So here I can say that the period of waxing, I will say